Learning to code can be a challenging and intimidating experience, especially for non-technical folks who are new to programming. It often requires a lot of time and effort to master the syntax, concepts, and tools of a programming language, and to apply them to real-world problems and projects. How can non-technical folks overcome the challenge of learning programming and creating their own software without having to master complex coding languages? And how can block coding help them achieve their goals by providing a visual and intuitive interface that simplifies the programming process? In the early days of programming, coders had to work with complex languages like assembly, C, and Fortran. These languages required a deep understanding of syntax, algorithms, and hardware specifications. With limited resources and guidance, learning and debugging code was a time-consuming and often frustrating process. As interest in data science grows across various fields, non-STEM students often face difficulties in programming. Visual tools like block coding can help them overcome these challenges and engage more effectively with data science concepts. Block coding platforms use a visual drag-and-drop interface where users can assemble pre-built code blocks to create programs. This eliminates the need to memorize syntax and reduces the chances of errors, making coding more intuitive and user-friendly. The roots of block coding can be traced back to the late 1960s with the development of Logo, an educational programming language created by Seymour Papert and his team at MIT.
Now, nobody really knows what the future will be like, but we know what it won't be like. We know it won't be lots of children sitting in desks with pencil and paper writing all the day. We know that these new technologies, these computers, will be an important part of it. Our goal here is to make it sufficiently part of the culture of the place that everybody uses it.
Today, block coding has become a crucial tool for teaching programming concepts, making coding accessible to millions of people worldwide, regardless of their age or prior programming experience. Several tools have been proposed to assist non-STEM students in learning data science. However, they all have limitations that prevent them from being fully effective for this audience. Enter Blockly DS, a prototype tool specifically designed to teach data science to non-STEM students. Blockly DS uses a visual programming approach that allows students to focus on data science concepts rather than getting bogged down by complex programming syntax. Blockly DS is built on the popular Blockly framework, which enables users to create programs by connecting blocks together. Each block represents a data science function such as data import, cleaning, transformation, analysis, or visualization. By connecting these blocks, students can quickly and easily construct a data science pipeline and see the results in real time. This hands-on approach helps students develop a deeper understanding of data science concepts without getting overwhelmed by programming. Luis Barbosa, Solutions Architect Manager at Blue Orange Digital, recently presented his work with Blockly DS for data science with visual, statistical, descriptive, and predictive analysis at the 13th International Learning, Analytics, and Knowledge Conference.
Blockly is an existing tool developed by Google. It's used to help the teaching of programming and coding for general audience. And we extend this tool with analytical features, either descriptive in order to create visual graphs, analytical descriptions, and also predictive analysis. The idea of my focus is actually to engage more with what's called non-STEM audience, humanities, liberal arts, healthcare, biological areas. First of all, when you're talking about coding, it's already an entry barrier for them. They found that very complex, very difficult. And once you're using a visual tool, a block-based tool, which looks like quite like a toy, like something to be played with little blocks, and then from that transition very smoothly into actual coding. The business benefit when you're talking about predictive analysis. So instead of limit yourself of analyzing past data, we can start inferencing or forecasting future data. If you want to forecast your the production or the revenue of your company, move from that to coding. And again, this transition seems quite a leap, but it actually isn't. Once you understand the concept and have very basic coding skills, it's very easy somehow to extend that and use your day-to-day, analyze your own data, do your own predictions, do your own inference. It's quite useful for any profession.
Blockly DS is currently being tested at 2 Brazilian institutions, IBM EC, where it is being used by undergraduate students in economics and administration, and Lumturo, a pre-university course. These trials aim to assess the effectiveness of Blockly DS in teaching data science to non-STEM students. Blockly DS has the potential to revolutionize the way non-STEM students learn data science, making it more accessible and enjoyable. With continued development and support, Blockly DS can help bridge the gap between STEM and non-STEM fields, empowering students to harness the power of data in their future careers.